So in this video, we're just going to look at the simulation. I'll show you how to use it, and I'll show you kind of a practice run on what it would look like when you get that evidence or data from uh, the simulation. So we'll look at the spreadsheet too. So we'll look at what it looks like to use the simulation, but also what it means to get information from the simulation and input it into our data spreadsheet. All right, first things first, I just kind of want to show you what it looks like if you try to initiate the simulation, some of the issues that might pop up that you may have to navigate. So I'm going to go to the original site here. So first you're already seeing, it's basically, do you trust this or not? You can keep or discard. Especially it looks like this you're using Google Chrome, right? So I'm going to hit keep. And once you hit keep, it doesn't look like it's doing anything. You may wait for it to initiate a screen to pop up, but it won't. You have to click this arrow here and click open. Once you hit open, like right now, it's not asking me to update anything. I've used this simulation before on this computer, but if on the computer you're using, you're using it for the first time, the simulation, it may ask you to update Java. You have options. You can say update, ignore, or you can click later. Or you can just back out of the whole thing. The option you'd want to choose is to update later. On school computers, that tends to be the best option, the one that will allow you to run it. So you can run this simulation on outdated or older Java software. You just have to click later. Now, for me, I didn't have to because I've already done it on this laptop before. But I will hit run here, so which is saying you need to do. So you click run, and it'll initiate. And here we are. And it ends up as an icon. Let me adjust just so you can see, just moving the screen down a little so you can see this icon here. This icon, you can see I have two opened up. I'll minimize one, but it's pretty cool to know you can have multiple windows. So you could be running simultaneously different experiments using this. But right now we have the natural selection simulation. And you can see it's in its own window that you click, right? All the bunnies died. So I'm just going to pause it right here. So it's paused, but that's essentially the process of getting to the simulation. Now let's just talk about different things that you potentially will need to do when using the simulation. So you always, based on the experiment you're doing, you're going to need to choose wolves or food. Wolves or food. Another thing you're going to have to choose for your experiment is the environment you're working in, equator or Arctic. The last selection you'll potentially choose is if there is a mutation or not. If your experiment doesn't call for any mutation, you're fine. If your experiment calls for a mutation, you need to either choose brown fur or choose long teeth. Someday we may use the long tail, but currently all the experiments are based on just these two different possible mutations, brown fur and long teeth. So no matter what experiment you have to add a friend. Now again, the simulation's still paused. So adding a friend allows them the potential to reproduce. And the way the simulation runs, it assumes one's a guy, one's a girl. Moving forward with that. The next thing you'll need to pay attention to is this right here. This green bar, which changes over time, represents generations. And let's just see what that looks like. So as it winds down, it's the end of the first generation, beginning the second. Boom. Now just to pause that, this was the first generation, and then when you see a step up, that represents a second generation. So the second generation has 1, 2, 3, 4, 5, 6. 6 individuals total, 2 of which were part of the first generation. Those are the parents. The second generation is the children, and there's 4 offspring. So let's just see, what would I do with that information? I have the graph here giving me data on the experiment. It tells me how many numbers we have. The bar goes just above 5, so we know we have 6 total. And we know we're in the second generation. So what would that look like using the data sheet? All right, I don't have a data sheet for this specific scenario, but I'm going to open a data sheet and just kind of show you, if it were part of the experiment, how you would enter that information in. So going back to the page we were on originally for the lab, kind of go down, and you can see here we have 12 different links, 12 different experiments to run. None of these experiments are based on what the simulation I currently have is, but I'm just going to choose the top one and just show you how to enter data in. So I would write Josh's group, and this is the first generation, generation 1. The first generation had 2 individuals because we added the friend, right? The second generation, and I'll just go back here just so you can see, the first generation only had 2 people, right? There was 1 bunny, then I added a friend, and then after that they reproduced and they had 4 offspring. So if you add the original 2 plus the 4 babies they have, the total population is 6. Very easy to count right here. In fact, it's easier to count these rabbits up here than it is to look at the graph. But soon enough, you're going to be wanting to use the graph rather than the top, just based on the numbers of rabbits. Especially if they're surviving really well, it's very difficult to count them all. And it's definitely impossible to count them unless you pause it, because they move around, right? So pause it, count between each generation. So there's 6 total. Let's go back to the spreadsheet. We'd enter in 6 right here. Notice something else. So as I've entered in the data here for my group, the averages change. So the average of 2 and 6 is 4. The average of 2 and 2, of course, is 2. And again, these first numbers weren't realistic. The current ones are, based on the simulation, but these ones were just made up just to kind of show someone how to enter in their data. So we've entered in that there were 6 people in the second generation. So the second generation we had 6 individuals. Let's go back to the simulator. Notice I paused it right in the middle of the second generation. Now I'm going to play it again so I can capture data on the third generation. I'm going to pause it. I'm pausing it right in the middle of the third generation, and you can already see by third generation there's a lot of rabbits to count. You can physically do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It says there's 18. How good of a counter are you, right? That's the question. So if it's really easy to count this, great. If you feel like you might make a mistake counting up here, or if you feel like there's too many, you need to use the graph down here. So let's decide, was I correct? Was there in fact 18? So let's zoom in. You can use this zoom function. So you can see if you zoom in too much, you kind of lose it. So it looks like there's a little flaw in the software and the programming. So you got to back it out one more time. And then it's kind of estimating. If you think there's 18, and this is kind of halfway between 15 and 20, it's likely 18. All right, one other thing that's useful to know, and let's enter in the data first. So we had 18. All right, the average now goes to 25.5, so it's always actively updating. So even if we had 13 different groups entering information, it's averaging it all. So on average, the third generation, given the situation or the experiment, would be this number, right? And averages tend to be closer to the correct number. So if one individual happens to make a mistake, it will throw off the quality of the data and how trustworthy it is or reliable it is, but it'll still not be as bad given we have so many different people adding to this average. Anyways, another positive. So Java's being removed from online content, and this activity will eventually be non-Java. But for the time being, the way it opens, I just want to show you that you can pretty much adjust the scale of the window, well, you can make it full scale, but let's see if we can shrink it down. So in it, you see how it auto adjusts? So it auto adjusts, so you could potentially keep this right here, and you could let the simulation run while also entering in data. Looks like the start and stop function has disappeared, however, so see if we can get that to reappear. So you can see there's no scroll bar, so if you minimize it too much, you can't access the button to keep the simulation going. Alright, 5 hours later, adjusting this window size, I was able to once again be able to see the play button. But I think you get the point. We'll do one more just to help you. So let's hit play. Alright, so the third generation just ended, the fourth one just began. And you can see that the data on the graph has gone out of view. So you got to you can zoom in or out, right? You can zoom in or out just so that we can focus on the data point and where it's at. Right now, I doubt you want to count all 50, right? So you can see the graph starts becoming a better estimate of the population. This is tedious. Now, you could do this, and some biologists out in the field have to count every single individual they see, right? It's observational study, but in this example, just estimate the graph's probably going to be faster, because ultimately we want to be able to answer questions. We want to be able to answer the original problem. And if we take too long to count these individually, you got a problem. So just go based on the graph. It looks like we have about 52 individuals. Actually, it jumps from 50 to 60, so it's probably going to be about 54 individuals if I had to estimate, right? So I'm going to estimate that the fourth generation had 54 individuals. You can see if you keep going, the averages will keep adjusting. And as you add this, you can always refer to this tab right here, which is actually giving active data. Because every time we change any of the information, these averages are updating, and it's auto-updating this graph. So this graph is a live document that's constantly showing what's happening based on the different experiments. There's 3 different experiments here, right? If you choose the equator, you have wolves in the environment, and there's a tooth mutation. Or if you have the mutation, brown mutation, right? Wolves are in the environment and the equator. What all 3 of these experiments have in common is that you're in the equator, and there's wolves that as a selection pressure in the environment. The only question is the difference between the 3 experiments is the mutation involved. Everything else is the same. And so once again, based on the experiment you're doing, you have to choose the right selection factor, the right environment, and whether or not you have mutations. If you don't have mutations, you don't select any of these. If you are counting mutations, you have to select one of these. I'm going to reset this just to kind of give you an idea of what that would look like to add mutations. We're going to do a full scale window. We're going to pause it. All right, first things first, we have to add a friend. So in this environment, let's pretend we're trying to simulate an experiment that had wolves. And they're already there. You can also add, change the environment, right? So in this environment, what we'll do is we'll let the population go to the second generation before we add wolves. So just in general, that's what we'll agree on. So as part of the procedures, if you're going to add a selection force, let's do that at the second generation. But at the very beginning, you need to choose the right environment. So it's one generation. We've added a friend. The next step is to choose the right environment. In this example, we'll do equator. And we want to identify a mutation. So in this example, let's say long tail. Now, there's no mutation coming because the mutation is as far as the software goes, results when you start the simulation. But here we go. We play it. Once the generation reproduces, that's when you add a selection factor, such as wolves. So you wait till the second generation.